This presentation shows you how to analyze binary data using ordinary multiple regression. Typically, multiple regression requires a continuous response variable. So in order to analyze binary data, we need to reorganize the data before conducting the analysis. These slides were organized by Farrokh Alemi. Suppose you need to analyze data such as this. Here, the dependent variable is participation in the medical foster home program, shown in the first column. It's either 0 or 1. We want to know if patients with different functional abilities are more likely to participate in the program. We can regress the medical foster home variable on the remaining independent variables. The problem is that we cannot use multiple variable regression, as this method of data analysis requires a continuous response, and here we have a binary response. So we set out to create a continuous response variable. First, we group the data and calculate the probability of the event within each combination of independent variables. This probability is shown here as pi. Then we calculate the odds of participating in the medical foster home from this probability. The response or dependent variable is log of the odds. The logarithm function is a number between 0 and infinity. When it is negative, it means that the odds are against the response. When positive, it means that it increases the response variable. At odds of 1 to 1, the logarithm is 0. The natural log of the odds is called the Logit function. It is a transformation that allows us to deal with probabilities without the awkward hard limit at 1. The Logit transformation can be regressed on the linear or a nonlinear combination of independent variables. If we were going to regress the probability on the same set of predictors, we may have had a predicted probability that was more than 1, which makes no sense. The Logit function does not have this hard limit, so it does not make predictions that cannot be interpreted. Since the regression was done using a Logit transformation of the probability, you may wonder how can this function be used to retrieve the probability of the dependent variable. If lambda is the predicted Logit response, the e to the power of lambda divided by 1 plus e to the power of lambda allows us to get the predicted probability, here shown as pi with a hat, to emphasize that it is a predicted value. The Logit transformations allows us to learn the relationship between the dependent variable and the predictors. The inverse of this transformation allows us to retrieve the probability of binary response variable. Okay, let's see how this is done. First, we prepare our data, and by that we mean that all predictors have to be a discrete variable. First, we break the independent variables into binary variables. Later, we will break these continuous variables into several categories, perhaps quintiles. For example, in analyzing the age, we currently look at above or below average age, but later we might look at age by decades. This is how our initial data looks like now. Each predictor is now a binary variable. Next, we grouped it by the binary predictor variables. This gives us several combinations of functional disabilities, age, and gender. For each combination, we calculate the probability. This is the pi in the earlier equations. So in the first row of these data, we see the situation of a white female in her 40s without any functional disabilities. There were 10 such combinations in the data, and none of them were in the medical foster home program. and this shows up with probability of 0. In contrast, there were 16 white females in their 50s, and 6% of them participated in the program, as shown in the second row. Here we see the Logit transformation of the probabilities. Indeed, it is these set of numbers that are regressed on the functional disabilities, age, and gender. Here is the result of the regression. We can now see that the participants in the medical foster home program did not differ in many ways from non-participants. There were two differences that were significant. Participants were less likely to have bathing disability and more likely to have transfer disability. So, to do a regression with a binary response variable, group the data by independent variables, calculate the probability of the response within the combination of the variables, transform the probabilities, and then do the regression.